All right, you guys, when I was looking at this, I was like, oh my gosh, there's a lot of connections I need to make, and I think I'll just make them in class. And so I'll just give you the basics here. We'll just act like these problems are, I don't want to say brain dead. They're not brain dead, but I'm going to give you the process to help you solve these problems. But in class, I want to make sure we get the pieces connected of why you're doing this whole thing, okay? It's not just some random junk you're just doing. Okay, so you are going to be learning how to solve quadratic equations. Now, you've already learned how to solve quadratic equations. If you recall, you learned stuff like this. Okay, you were given stuff like this. You set it equal to 0. Remember, that was it, so we could use the zero product rule. Okay, and then you factored it like this. And then you found out that x was equal to -1 or x is equal to -2. See, the thing is a quadratic. A quadratic, remember, is a parabola, and it's possible that it has two real solutions like this. It could be it could touch the x-axis twice. It's possible it could have one solution, okay? That's where it just comes up and kisses the x-axis. That's one solution. Or it could have two imaginary solutions. When it floats, it's got two imaginary solutions. Now, here's the thing. It always has two factors, meaning two things that multiply together. But if those factors are the same thing, it only has one solution. For example, if you factor something and it was like this, x minus 1 times x minus 1 equals 0. Well, there's only one answer, x equals 1. That's the case where it just comes and kisses the axis, okay? But it happens twice. Just so you know, there are two roots, but there's really only one solution, okay? So what we're going to do today is we're going to actually kind of head into this zone here, okay? We are going to try to create this situation, a perfect square trinomial. And what that means is when you have this situation, like x minus 1 quantity squared, okay? You guys, you could either do this. Remember I told you mark it, like when you see a square, write it out. Here it is written out. So if you FOILed this out, you get x minus x, right? X squared minus x plus 1. And then you would get x squared plus minus 2x plus 1. Okay, the idea is that we are going to take advantage of this and go backwards. We're going to try to create this situation right here. That's what completing the square is all about. Okay, completing the square is trying to create a perfect square trinomial so that you can go to this situation right here, x minus 1 squared. Because if we can get something in a quadratic form like this, we can take the square root. Okay, kind of a general idea. Now, to solve it, there are very specific steps you have to take. Okay, I'm going to go ahead and erase this. Okay. So the specific steps you take are all about getting to the point where you can complete the square. So you have learned how to complete the square already. That was where you did basically, I'll just do this, basically where you took the middle term and you divided by 2. If you don't remember, it looked like this. You had something like this, x squared plus 8x, and then plus, and then it asked you to find that number, and then you had to take 8 divided by 2 quantity squared. Now, that's kind of a memorization thing. There's nothing like intuitive about this at all. And that would become 4 squared, or 16. So that would be 16. Okay, and then you might also have this situation, x squared minus 10x plus what? Now, here's the cool thing. It's always going to be plus something. Whenever you complete the square, it's always plus, okay? Because look, if I take -5 and divide by 2 and then square it, I'm going to get 25/4. Okay? It's positive. No matter that it's negative, negative times a negative is a positive. So whenever we complete the square, we're always adding, okay, instead of subtracting. The difference, though, is that if you have a perfect square trinomial, a squared minus 2ab plus b squared. Remember, this is what we're trying to create with completing the square. We're we're creating this situation. It's a cool little trick that we are using. This becomes a minus b quantity squared. There, see the minus? That is where that comes from. It's always going to be a plus b squared, but the minus is here. A squared plus 2ab. When we factor this one, okay, we're going to get a plus b squared. Now, if you don't understand where this is coming from, you should actually factor it. You'd be like, a times a is a squared, b times b is b squared. I need a positive, same sign, it's positive. Oh, it's a plus b quantity squared. Like, you really should know where this comes from. You should know why we go from here to here. This is the formula. This is the formula for the negative. This is the formula for the positive. It assumes you know this. You should write this down. This should be in your notes, and it should be accessible for you. All right, so here we are. We are going to complete the square on this, okay? So it says choose the appropriate form, meaning between these two, and fill in the blanks with the correct numbers. Then solve the equation. Solve means find the answer for x. If there's more than one solution, separate with commas. All right, so here we go, okay? I am going to go ahead and change out for purple. Okay, I did already. Okay, let's shut that down too. All right, so first we got to go x squared plus 14x, okay, plus 38 equals 0. So here's what I'm going to do. I am going to move the 38 over to the other side. Okay, why? Because I want to complete the square. Now, when we do this in an equation, we won't actually do this step. It'll be slightly different. We'll leave the 38 there, but for right now, we're going to move it over to the other side. We subtract 38. Then we complete the square. So x squared, you're going to take 14. You do this on the side somewhere. 14 divided by 2, quantity squared. So 14 divided by 2 is 7. 7 squared is 49. So we are going to add 49 to complete the square. So 49, and you guys might want to be writing directions. I'm going to go ahead and erase this because it's in the way. Okay, let me go back to purple. All right, here we go. But you can't add something to one side and not add it to the other. So we have to add it to both sides of the equation. This is an equation. Now we have created, this is the beauty of this, we created a perfect square trinomial. So you factor it like this, and that equals, and then you subtract here. It's 1, 9 minus 8 is 1, 4 minus 3 is 11. Okay, well, the whole point of doing this is so you could get a square, perfect square, so we could then take the square root of both sides. And then the square root of a square is going to be x plus 7, and that's going to be plus or minus square root of 11. Now, you can't find the square root of 11. Do you see it says with exact answers, this right here? That means leave the square roots. You have to simplify them. If you can find like a perfect square within that square root, you have to simplify it, but you leave it. Now I need to solve for x. This is not solve for x. I need to subtract 7 from both sides. So I'm going to get negative 7 plus or minus the square root of 11. Now you might want to leave it like that, but I'm not going to let you in the beginning. I want you to list both roots. Okay, so you would have to do this. Actually, I think Alex is going to make you do this anyway. 7 plus the square root of 11, comma, 7, negative 7 minus the square root of 11. These are the two roots, and if you were to actually get their decimal value, you would see that that is where they cross the x-axis. Okay, let's go to the next one. Again, pause it if you need to. Okay. I did do a few problems because this is hard. This is new. Okay. So taking a look here, you got x squared minus 2x minus 10 equals 0. So first of all, let's pretend you were given this problem and you were asked to solve it. The first thing you do is like, could I factor it? Well, guess what? You actually can factor this. Okay. And I would, if it were me, this is what I would do. I'd be like, I can do this. Ready? X and x minus minus 5. Oh, no, I can't. 5 times 2 is 10, but that would give me a 3. Never mind. But I would try factoring first, and it didn't work. So then I'd be like, oh, okay, I got a choice. I can either use the quadratic formula or completing the square. And since we haven't learned the quadratic formula yet, you can't use that. Okay, that's my favorite, by the way. All right, so we're going to complete the square. So the first thing you want to do is move C to the other side. Okay, move C over. That's my shorthand. Okay, so we're going to get x squared minus 2x and then plus something. Leave room for it. Okay, leave room for completing the square, and then you are going to complete the square. How? We're going to take a negative 2, divide by 2. You take negative b over 2, square it. Okay, actually, you don't even take negative b. You just do b over 2 and square it. So, and you might want to write that down, y'all, over and over again until you get it. B over 2 squared. Okay, so negative 2 over 2, this becomes negative 1. Negative 1 times negative 1 is 1. So we just go 1. But you can't add it to one side. You must add it to the other side. So we get 11 here. And then you factor. Step 3 is factor. So we created a perfect square trinomial. So now what we have to do is factor this perfect square trinomial. X minus, because the minus sign comes down, 1 squared. Okay, yay! We created a situation where now we can take the square root. Okay, so the next step is take the square root of both sides. So I'm going to do it in a different color just because. So I'm going to take the square root of both sides. Okay, and when I do that, I'm going to get rid of this. The square root of the square. The square root of a square cancels each other out, right? This cancels out that. And you get x minus 1 equals plus or minus the square root of 11. That's the irrational part. This is the rational part. We need to solve for x. It's not solved yet. So we need to add 1 to both sides. 1 plus or minus the square root of 11. So how do you write that separate? X is equal to 1 plus the square root of 11, or x is equal to 1 minus the square root of 11. Okay, so I hope what happened with this is you followed along in the first two problems. I assume that's what you would need to do. This is not super easy, and it's not super like, oh, I get it. Like, it's kind of a trick. It's a cool little trick, but it's still kind of a trick. All right, now it says quadratic formula. Okay, so looking here. Oh, by the way, let me make very, very clear. In these two problems, do you notice that a is equal to 1? A always has to be equal to 1 or completing the square. In fact, I think I'll write that down. I know I wrote it down already before. I'm going to write it as a big star. A equals 1 for, oh my God, my pen, you guys, completing the square. It's only when I'm recording that it acts this weird. Okay, square. Yes, I will be looking for that in your notes, by the way. A must be equal to 1. So in these next problems, check it out. The first one, okay, look. Sorry, went the wrong direction. Okay, look. In this one, A happens to be equal to 3. So we have A equals 3, B equals 1, and C equals negative 8. So if I were to complete the square, I would literally have to divide everything by 3. So I would have to do, I'm just going to show you. You don't have to copy this down, but watch this, because look at how icky this would be if you decided to complete the square. You'd have to divide everything by 3 because we got to get a to 1. And by the way, you'd have to do both sides. And then you would get x squared plus 1/3 x minus 8/3 equals 0. And then you would have to do 1/3 divided by 2, which is the same thing as times 1/2 squared. So you would get 1/6 squared, which is 1/36. So you see how it gets it really nasty into fractions and stuff. So we don't really want that, but don't be surprised if I eventually ask you to be able to be at this level, okay, of working with fractions. I just wanted to show you that that's not the best way to solve this. It kind of sucks. Like if that were the only way to solve it, it'd be like, ugh, do I have to? I don't want to do that. All right, so I'm going to teach you the quadratic formula. Okay, quadratic formula, I want you to know this because this might save your like math career here. Quadratic formula works all day, all day, every day, every quadratic. So the cool thing about the quadratic formula is there's nothing special about it in the sense that quadratic, every quadratic, okay? It doesn't matter. It could be simple, it could be complex, it could be weird, but once you set it equal to 0, that's the only stipulation. It must be set to equal to 0, but that's standard form, okay? So set equal to 0 or standard form, okay? Then you can define A, B, and C, and then you can use it. So here it goes. It goes x is equal to opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So speed to pop goes the weasel. All around the mulberry bush, the monkey chased the weasel. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A, whatever. Okay, the idea is that you can remember this, all right? I just say X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, what does that mean? It means you plug in A, B, and C accordingly. You define them, and then you plug them in. So here we go. I'm going to rewrite it, and I want you guys to write it until you know it. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A, except for not that piece over there by the X, because we don't do that. That's weird. Okay, here we go. Don't go with the equal sign. Miss Baca, that was goofy. Now I'm going to erase the parts and plug them in. Ready? It said opposite of B. What's B? 1. Okay. Then B squared. Put it in parentheses, people, and you'll not screw up. Okay. I know positives don't matter, but negatives do. Okay. Ready? What's A? I'm going to plug it in here. A is 3. And then what is C? I'm going to erase C and plug C in. C is negative 8. All over 2A. So now we're going to plug in A here. Come here, erase that. Okay. And so A is equal to, hang on. A is equal to 3. Okay, so negative B plus or minus square root of B squared minus 4AC all over 2A. And now you do the math. Don't lose the X. Everybody loses the X. Don't lose the X. Plus or minus the square root of 1. And then this is going to be 4 times 3 is 12. 12 times 8 is, oh my God, what is 12 times 8, you guys? 96. So plus 96. Do you see? Because it's a negative times a negative. Okay. All over 6. So X is equal to negative 1 plus or minus the square root of 97 all over 6. So the final answer looks like this. X equals negative 1 plus the square root of 97. By the way, I can't simplify 97, can I? Does 3 go into 97? Nope. All over 6. I don't know why I keep doing that. Stop that. Okay. Or that was mustard. It was not anything else. Okay, that was really gross sounding. Okay, if you heard that. Okay, -1 minus the square root of 97 over 6. Okay, those are your two answers. And that is how you express them as well. Sometimes they'll have you separate these into two different fractions. I don't know if Alex wants you to. I am used to this, but sometimes people do this. Okay, just be aware in case Alex teaches it that way. Okay, next. Quadratic formula to solve for, here we go. Okay, so A equals 4, B equals 6, C equals 1. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. My pen doesn't like curves. Okay, so x is equal to negative b is 6, plus or minus the square root of, put it in parentheses, 6 squared minus 4 times a is 4, c is 1. Oh my God, I'm so sorry. Okay, all over 2a, 2 times 4. So x is equal to negative 6 plus or minus the square root of 36 minus 16 all over 8. Okay, not done yet. You have to have a lot of patience with these because they go all the way down. Sometimes you have 8 lines. Plus or minus the square root of 20 all over 8. Still not done. Let's go over here. Okay, so then you go, okay, square root of 20. There's a perfect square that goes into 20, and that is 4. It is 4. 20 is equal to 4 times 5, so we can break this apart. So it's x is equal to negative 6 plus or minus the square root of 4 times the square root of 5 all over 2 all over 8. Sorry, I already did 2a. I can't see it. Come on, honey. Okay. All over 8 times 5, right? This becomes 2. Okay. Still not done. X is equal to negative 6 plus or minus 2 root 5 all over 8. Okay, separate it. The reason why is I want you to be able to see that 6 and 2 and 8 are all divisible by 2. You can't ever divide like here. You can't divide here. See 6 and 8 right here? You cannot divide them because this piece is not divisible by 2 right here. So you can't divide pieces. You cannot divide pieces of a fraction. Just real quick, I'm just going to show you this because this is a huge common mistake. This is not true. You can't cancel a piece of a number. This is supposed to be 5 halves. 2 plus 3 is equal to 5 and 2 halves. If I cancel the 2, all of a sudden it's equal to 3, and that makes no sense at all. So you cannot do that. So over here, sometimes it's easier to understand if you separate it. 6 over 8 plus or minus 2 root 5 over 8. And then look, 6 is divisible by 2, you get 3. 4, 2 goes into 2 once, 2 goes into 4. So the final answer is, let me move this up real quick. The final answer is x is equal to negative 3/4 plus the square root of 5 over 4, or x is equal to negative 3/4 minus the square root of 5 over 4. Okay, it can also be written as negative 3 plus root 5 all over 4. That way. I don't know which way Alex is going to ask you. It depends sometimes on its mood too. So, okay. All right. So it can be written like this, or like this, okay? Two different ways to write it. Next, here we go again. Okay, now it's complex. Now we're going to get to the floating, which means we're going to get imaginary roots. Okay, so ready? A equals 11, B equals -5, and C equals 2. All right, here we go. X is equal to -b plus or minus the square root b squared minus 4ac all over 2a. Miss Buck, do I have to write it every single time? Yes, you do. Yes, you do. Okay, so the opposite of b is going to be, b is -5. The opposite of b is 5. Plus or minus the square root of b squared, put it in parentheses so you don't screw up, minus 4 times 11 times 2, all over 2 times 11. X is equal to 5 plus or minus the square root of, and then now do the math. 25 minus 4 times 2 is 8. 8 times 11 is 88, all over 22. Keep going. Okay, we're going to come up here. Okay, X is equal to 5 plus or minus the square root. What is 25 minus 88? Well, 88 is bigger. So 8 minus 5 is 3. 8 minus 2 is 63. Negative 63 all over 22. Is there a perfect square that goes into 63? That's what you have to ask next, and the answer is yes. Plus, we can take the square root of a negative number now that we're like we got our big pants on, so to speak, our math pants on, okay? We can do this. Break up 63. It's -1 times 9 times 3. That's 63. Wait, 9 times 3 is not 63. 9 times 7. I don't know what I was saying. Here we go. Boom. 9 times 7. Okay. All over 22. Now you can take the square root. The square root of 9 is 3. The square root of -1 is I. So rewrite it. X is equal to 5 plus or minus 3I root 7 all over 22. Now, can you simplify it any further? No, there's not any common factors, and 7 can't be simplified. 3i, I think I might be wrong, but I'm pretty sure that Alex makes you rewrite this like this. 5 plus or minus 3 times the square root of 7. Like they have you put the real piece, then the imaginary piece multiplied there over 22. Okay, you can let me know. You will find out. Just check the explanation. Okay, last thing. Not last thing. Next problem, rather. A equals 5. B equals -6. I recommend you pause the video and try to solve this problem on your own. Okay, X is equal to -b plus or minus the square root of b squared for AC all over 2a. Okay, X is equal to the opposite of b, square root of, plug it in. Pause at any point where you feel like, okay, wait, I need to try this all on my own. Or let me finish this problem before she does it, because I know I work fast. Okay, X equals 6 plus or minus the square root of 36. And then 4 times 5 is 20. 20 times 2 is -40. All over 10. And then we got to come up here. X equals 6 plus or minus the square root of -4 over 10. X is equal to 6 plus or minus. Now you could take the square root of -4. It's 2i. The square root of 4 is 2. The square root of -1 is I. So 2i over 5. Now, do you see how, over 10. I don't know why I put 5. You see how, that's ugly. Sorry, guys. Here, I have to erase that. Okay. Do you see how every single one of these is divisible by 2? There we go. So we can reduce this. This can be reduced to 3 plus I over 5. Make sure you understand what I just did. I divided 6 by 2, basically did this. I divided 6 by 2, 10 by 2, and 2 by 2. They all three have to be divisible by 2 in order for you to do this. And that is the answer, 3 plus or minus. So you would write x equals 3 plus I over 5, or x equals 3 minus I over 5. Okay, next. All right, the last thing is to find the discriminant. And for today's notes, all I care is that you know that the word discriminant and what it means. The discriminant is b squared minus, it's the inside of the quadratic formula. This whole piece, b squared minus 4ac, the discriminant is this little piece right here. Okay, because think about this. If you have the square root of a positive number, you're going to get 2 real roots, correct? And if you have the square root of 0, you're going to get 1 real root. And if you have the square root of a negative number, you're going to get 2 imaginary roots. This is what they want you to know. That right there. They need you to know that. And that's what we're going to do. If the discriminant is positive, then we know we get 2 real roots. If the discriminant is 0, we get 1 real root. And if the discriminant is negative, we get 2 imaginary roots, because you can't take the square root. I mean, you can't get real numbers when you have a negative inside the square root. All right, so A equals -3, B equals 7, C equals -4. All right, we're going to do b squared minus 4ac. That's all you're doing. B squared is 7 squared, put it in parentheses if you need, minus 4. Actually, it's good practice. -4. All right, 49 minus, okay. Well, I don't know if it's minus. Yeah, it is. It's negative times negative times negative is minus. 4 times 3 is 12. 12 times 4 is 48. And the answer is 1. So you are going to get two real solutions, because that is a positive value. Notice it says give the number of real solutions. That probably means you have a choice of 2 real, 1 real, and 0 real, which is when it's imaginary. Try again. A equals -2. This is the last topic for today, you guys. -6. So b squared minus 4ac is 1 squared minus 4 times -2 times -6. You get 1 minus 48. Wow, that's one ugly 48. You get -47. So it's negative. Negative means there are no real, because they're both imaginary. Remember, real actually means real numbers. All right, I don't think there's another one. Nope. All right, that marks the end of these notes.